Now we will talk about the higher order Runge Kutta function, numerical method. So Runge Kutta method, which is refer to a whole range of method that use a truncated Taylor expansion without requiring the calculation of higher derivative. Okay, so we talk about Wheeler's method, modified Wheeler's method. They are first order and second order Runge Kutta. There are higher order Runge Kutta, and basically the ODE function inside the MATLAB is based on Runge Kutta method. Okay, so without calculating higher order derivative, we use the Taylor expansion, which is yn plus 1. In general form of Runge Kutta's method, will be equals to yn plus phi xn yn h. And this yn sometimes will be yn plus 1 star, etc. Those are the increment function. Which can be evaluated or interpreted as a constant slope, or you think as an average slope. And this h will be your step size. The xn will be, the independent variables. So that is basically the general form of Runge Kutta's method. And we already talked about the first order and second order. Here we just gave a general form of the fourth order Runge Kutta's method, which is very often used in the MATLAB. You know that ODE 45, that 4 means the fourth order of Runge Kutta. ODE 23, this 2 will be means the second order Runge Kutta. The 3 will be the third order Runge Kutta. So just to give a general form, and you can use the examples of our Wheeler's method, modified Wheeler's method, that example to see whether this fourth order Runge Kutta can increase the accuracy a lot or not. Okay. So the fourth order Runge Kutta method. We will use similar algorithm. We will talk about the algorithm here. And similar to Euler and modified Euler, that is, we will calculate, basically, evaluate K1, evaluate the function. K1 is hf xn yn. K2 equals hf xn plus half h yn plus half K1. K3 will be equals to hf xn plus 1/2 h yn equals yn plus 1/2 of K2. K4 will be equals to hf xn plus h yn plus K3. Then the second step, we will evaluate what is our increment function. So increment function is yn plus 1 will be equals to yn plus 1/6 K1 plus 2 K2 plus 2k3 plus k4. Then the third step is you update your independent variable x, so increment of the independent variable xn plus 1 equals xn plus h. Then you repeat all the steps until finish scanning all the terms of x. And you know, for the Euler's method, we only evaluate one function per step. For modified Euler is 2 functions per step. So for fourth order is 4 functions per step. And you can think in terms of the computational expense, it will be much more expensive as compared to the first order or second order Runge Kutta, but it will lead to a higher accuracy. Okay.